Hello, everyone. Welcome to day 3 of Launch Week 5, which is all about community. SigNoz has been open source first since day one, and our community makes us better every single day. They contribute code, report issues, and help each other solve problems. So, today's updates come directly from community feedback about making self hosting easier. So, let me bring in Vikrant, who worked on these community improvements. Vikrant, can you please introduce yourself and show us what we are shipping today?
Yes, so hello everyone. I am excited to be back at launch week again. So this is a really exciting time because this time we have worked on some nice community improvements based on a lot of feedback that we got from our users. And it's always exciting to work for the community and make lives easier for them as well. So we had a couple of issues that we had to work on. So there was one of the most asked features and one of the most requested features from our community users. That was please let us support different relational databases apart from SQLite. Nobody likes to run SQLite in production. So yes, your requests have been heard, and we have added the support so that you can run different relational databases with your SigNoz instance. And let's do something daring today. Let's start with a live demo of the feature. Let me just share my screen. Right. So I've cloned SigNoz locally. And if you go to the deploy section of deploy folder and then inside Docker folder, you have a Docker Compose YAML, which lists all your basic services. You have your in the services section, you have your ClickHouse service, you have your Zookeeper service, and then you have your Sigma service, your collector service, your schema migrators for your ClickHouse schemas, and the basic network setting up and the volumes. Now, setting up Postgres is as easy as just adding another service here. Let's say I add a Postgres service. We're using the image as Postgres 15. You can just name your container and you can just set your SigNoz database here and the default user and the default password. And that's it. You can just set a volume so that your data survives your container restarts. And last but not the least, this is your Postgres service. In the SigNoz service, you have configuration variables. You can set SigNoz SQL store provider, which is Postgres, and your DSN for your Postgres instance. This is my Postgres, this is my database, username, and my default password and the SigNoz database. Now let's run it. I am in the root folder. Let me go to the deploy Docker folder, and here is my Docker Compose YAML. So running Postgres is as easy as just running Docker Compose up. And see, Postgres is being set up, volumes are being set up, and a Cygnus container is being set up. And meanwhile, let's just see what is happening here. So you have your Postgres up and running. Let's wait for SigNoz to be up and running. And let's just check our Postgres instance. The schema is in place. Your Postgres instance has your upgraded schema. All the schema migrations have been done. If you want to see the state of migrations, let's just check schema migrations. And you have all your 47 migrations being run. So your Postgres instance is ready. Now, since you log SigNoz on local, you can visit localhost 8080 and let's just sign up. Let me just add my email, SigNoz. Let me just set some dummy password and sign. And you have your SigNoz instance up and running with your Postgres relational database. And let's just verify. Let's see, since I created an organization, select start from organizations, and I have your SigNoz organization being set up. And let's see the user that I just created, and your user is being set up as well. So setting up Postgres is as straightforward as this. And if you see .ps, everything is up and running, everything is healthy. So that's it for the live demo. With these some basic configuration options and adding just a service to your Docker Compose, you can run your SigNoz instance with your Postgres instance. Now let's talk a little bit more about what all things went into making this possible. Uh, in a running production instance or in a running SigNoz instance, there are two things that how we interact with the relational database. First is you need to run some DDL commands and you need to be able to run DML commands. You should be able to manipulate your database layer structures. You need to be able to run schema migrations, change the structure of your tables, columns, indexes. And the second part is you should be able to query your data in a database agnostic way. To make this possible, a couple of work went into it. So the first one was let's make our SQL Store database agnostic. Let's start with the query layer. We built this SQL Store package that makes you query your database without even being concerned about what actually the database is being running in the background. Let us go to the GitHub repo and I'll walk you through some basic code structure here as well. If you go to pkg and you can find your SQL Store package here, and you have a SQL Store package. This SQL Store package exposes an interface. We can see here SQLDB. This is a database agnostic SQL function. This exposes a basic Go SQLDB interface where you can run your queries, any kind of queries that you want to run. You can join across tables and do whatever you want. You have certain support of running things in transaction, running SQL queries in transaction as well. And you have a basic SQL dialect as well, where you want to get some columns or where you're going to convert some data from integer to Boolean or integer to timestamp. Now, if you see, you have another support for SQLite SQL Store here. If you go to the provider, you create another SQLite instance here. In the new provider section, you launch a SQLite instance, and the SQLite instance is being passed as it is to your SQLDB interface. Now, the SQLDB interface is used to query across your entire application. So, your entire application runs queries and write queries in a database agnostic way so that you can run any relational database behind the scenes. This is all about the query layer of it. Let's see the migration layer of it as well. To make migrations database agnostic, we added a SQL migrator package and we added a SQL schema package. Let's start with SQL migrator package. You have a SQL migrator package in the pkg folder itself. And if you see the migrator.go, this migrator.go again accepts a SQL store parameter, which is again how you want to query your things, how you want to interact with your database without really worrying about what actual the database is. This migrator package takes off the SQL store and run all the migrations irrespective of it. And where actually we run the migrate commands here, and it just locks the database, it runs the migration commands, and then it unlocks the database. And we also have support for locking and rollback here. Let's see how the actual migrations are being written. If you see the SQL migration package, if you let's just open quick filters. So you add your keys, what are the filters that you want to add, what are the other table changes that you want to occur. You begin a transaction here. Nowhere here you really know about what the actual underlying database is. You just select a table, you select a column, and you get some data out of it, and then you just insert certain other rows into this database. Here, nowhere actually you are cared about what actually the underlying relational database is. Apart from these two, we also have a SQL schema package where you define all your DML queries. You have indexes. How can you generate indexes? How can you specify your indexes? To convert them into actual SQL commands, some basic formatters, which again depends on what type of database you're using, because underlying we need to convert a database agonistic language to a database aware language. You have your SQL schema, which takes care of all the different uh, what do you say, all the different constraint stuff with SQLite supports. How do you write certain queries in SQLite versus how do you write certain queries in Postgres or MySQL? So you have certain SQLite based commands here, which gets you the table, which passes the create table command. You have certain functions which passes all the columns. So this is all about how you can set up multiple relational databases. What all goes behind the scenes to make it possible? If you summarize all of it into two steps, the first one is how to make querying possible without knowing about the database, and the second is how can you run migrations without knowing about the database. So this is how you can set up easily various relational databases with SigNoz. Let's talk more about another things that I want to touch base on is there were multiple asks like we want to support MariaDB, we want to support MySQL, but why did we go ahead and implement it with PostgreSQL? Why not something else? So PostgreSQL has a lot of benefits on top of in comparison with the SQLite database. You get a lot of multiple user support. You can, let's say you have a Postgres instance up and running. Let's say you just want to you're using it for other applications as well, and you want to use it for SigNoz as well. So it's as easy as you just go ahead and create another SigNoz database in the same Postgres instance, create a user which only has access to your SigNoz database, and you can use that user in your SigNoz instance. So having these isolations, having multiple user support, having better access control is one of the key features why we went ahead with Postgres. Also, Postgres, since we now support IAC as well, you have Cygnus Terraform provider, which lets you create dashboards and alerts via code. So having multiple people writing to the same Postgres, same Cygnus instance becomes very tricky. In case of SQLite, you only have a single writer principle in which only a single person can write at a point of time, and the other people either have to wait for it or either they'll stuck in a deadlock where they're waiting for it, or either their queries are getting cancelled. With Postgres handles the transactions and locking mechanisms in a very efficient way. Also, other benefits of Postgres is it has auto maintenance background processes like auto vacuum, which takes care of better resource utilizations behind the scenes. You don't need to worry about it at all. Last but not the least, Postgres has a very nice support for backups. Backups become very important when you're running production databases. You need to be sure that your data is safe, even if something catastrophic happens. So Postgres gives you nice point-in-time backups, nice out-of-the-box backups, and nice backup recoveries as well. It becomes very tricky for backups in SQLite. You have to copy your files, and all those permissions come into picture. Since we are into observability space, the monitoring of Postgres instance is very crucial. And Postgres out of the box give you a PG stats view table, which lets you understand your slow running queries, your long running queries, what are the patterns of your lockings, what are the patterns of your connection poolings, and all of those things out of the box. So Postgres is actually an enterprise ready database which supports a lot of these things, which might be a little hassle to implement and even perform in SQLite. So these are one of the reasons why we went ahead with Postgres as our first native support. And since we were already diving too deep into relational databases, how they work, how we can make it agonistic, how we can make multiple relational databases supported, we thought why not go ahead and let's talk about a little of our schema as well. We did a couple of changes to make our schema more scalable. So if you see my screen, this is our current schema for SigNoz. So this is a Snowflake model. Now, why we went ahead with Snowflake model? Why not with a star model or something else? So Snowflake model represents a highly normalized database. And when you're building such a scalable infrastructure, when you're building such a scalable application, you need to be you don't need to be concerned a lot about if your database updates are synchronized, if the updates are consistent, how do you want to do updates, is how is the data stored. So getting normalization into picture, you don't need to worry much about your constraints. You have all your foreign key constraints into place, which lets all the bad updates do not happen. The bad updates are blocked out of the blocks, and all the benefits of a normalized database applies when you use a Snowflake schema. So you don't repeat yourself across table. Let's say some data is stored in some table, so you don't need to worry about the same data being stored in some other table, because whatever table needs the data, they'll already have references to the main fact table. So your storage efficiency increases. You don't need to repeat the data again and again. You don't need to worry about updates because you only have a single source of truth. You have a very better visibility into the hierarchical structures. Okay, this table is particularly dependent on these two tables, and so on and so forth. So having a normalized schema, having a Snowflake schema helps you build scalable systems, help you with row updates, the data updates. They are being very consistent, helps you overall with storage efficiency when once your data becomes very big, and so on and so forth. So these are the couple of benefits of our current schema design as well, and the choice of Postgres as a database. Let me walk you through the schema as well. So right in the heart of the schema is your organizations. So as we just saw, when you sign up onto your SigNoz instance, you start by creating an organization. So our organization is the heart and soul of your SigNoz system. Everything relies on organization. Once you create an organization, your users are created. You create another user, which is linked to your organization by a foreign key relation. And then again, a user can have passwords. A password can have a reset password or a challenge password. A user can have an API key specific to the user. A user can have certain user preferences. If you see very clearly, all the hierarchies are upfront visible. You see, an organization has a user has a password can have a reset password token, a user can have an API key, and a user can have some user preferences. So this hierarchy becomes very visible when you implement a Snowflake database. Now, let's see one more. Let's say an organization has a rule and an organization has a plant maintenance. Now, what this plant maintenance applies to which rules is clearly conveyed by a plant maintenance rule table. This plant maintenance applies to these three rules. This plant maintenance rule has a dependency on both the tables. You can clearly see with these two relations here. Again, an organization can have dashboards, an organization can have integrations, organization can have notification channels. So the overall hierarchy structure, the overall relationship modeling becomes very evident with this schema.
So, Vikram, were these changes needed for Query Builder version 5? Because
Mm,
when you're explaining it to me, I have a hunch that this is what was required as the base structure.
So a couple of things were required. Like we had to restructure, we had to migrate a couple of databases to a new structure to support the new query builder as well. But the schema changes were because we wanted to make our system scalable. Now we were adding support for relational databases, multiple relational databases. We actually wanted to use this time to revisit our schema and make it more performing, make it more consistent, make the updates more consistent. Because as we scale, your schema is the heart and soul of your system. So you, if your base is strong, if your schema is strong, you don't need to worry about how you can add another table, how you can add another relationship. Things becomes all the new updates and all the new features become like a breeze. Once the base schema is very solid. And since we were expecting a lot of scale as well, the number of rows in each table is going to increase. So we actually did a very nice thing. We earlier relied on random UUIDs. Now we went ahead and added UUID V7s. So UUID V7, the difference between a normal UUID and a UUID V7 is UUID V7 are sorted by timestamps. So let's say at a particular instance, you create a UUID, and let's say 20 seconds after you create another UUID, the second UUID will be if you sort them in ascending order, the second UUID will come after the first one. So they're lexicographically sortable. So what benefit it gives us is when you have a large database, the insert times become very low. Let's say I've added an index on the ID part, and since it's already sorted, the insertion time in a binary tree becomes very less. So the the write cost reduces significantly. So this was one of the other things that we did while we were scaling the whole schema.
Nice. So, Vikram, one thing I would like you to focus on is that, okay, so we made these particular changes and I understand why we made those decisions. Can you focus a bit on what it means for the end user? The moment they get done with these setups, what it means for them, what change will they start experiencing?
So probably they'll start see better experience in terms of performance. The queries will become faster because
Mhm.
Postgres natively supports a lot of query optimizations and a lot of indexes as well, which were not very easy to implement in SQLite. So you'll start seeing better performance. You'll see a full-fledged power of a enterprise-ready Postgres database out of the box. You can use any database of your choice moving ahead. Later we start supporting MySQL or MariaDB, so you can easily shift between databases as well. The life generally becomes easy. Management of a Postgres instance is easy. You don't need to rely on file-based databases anymore, and so on and so forth. There are a couple of improvements that they'll see, and since the schema is also updated, so that also adds up to the whole scenario.
We chose open telemetry because we want to keep it vendor free or, no lock-in. Is this a step towards that too, but for databases? Like, would you like to put it in that words?
So basically, you should have a choice. You can say in those terms that that's agree that We don't want our users to log into SQLite just because we started with it. So you have a choice of your database. You're comfortable with a certain database. You have an expertise of a certain database and you want to use it, or maybe you're already using it. So it just opens up a horizon of databases which you can choose based on what you feel is right, where you feel you're more comfortable storing your data. So there's a step towards a more democratic environment.
Oh, that is nice. Yeah, that is a nice part. So before this, they were not able to choose their own database. They
So
were
no,
restricted. Ah,
yeah, they were
okay.
restricted to SQLite database, but our query layer and our migration layer. So we wanted to support multiple databases, but that had to go through a major revamp because we had to make those two layers agnostic. So once we did that, now supporting new databases is just a breeze.
Oh, nice. I think this is a good point that I would like to add also to the discussion. So, yeah, Vikrant, with that, I think we have come to the end of the demo. But what new features can the OSS community expect coming in future? Because we understand that you have made a very rigid foundation for databases now, and I'm sure that there are many features planned to be layered on top of it.
Right. So there will be certain features on top of databases, what kind of different databases can you bring? How can we support multiple features out of the box as well? So more about that once we do that. But there are a couple of other improvements for the OSS community that I would like to share.
Oh, yes.
So just give me a minute once again. So let me present one interesting OSS improvement that we have been doing for quite some time now. Let me just share my screen. And if you go to the docs section of our website and in the self-hosted section, we have added a bunch of install options in our website. You can install SigNoz, self-hosted SigNoz via Docker, binary, or Kubernetes, and some other platforms as well. So we earlier had support for standalone and Docker Swarm, but now we added support for Docker SE Linux as well. And all these docs are pretty detailed. You can just go to each individual doc and you'll see a bunch of instructions and a bunch of helpful text that you need to be aware while running it on those platforms. Apart from this, if you can install SigNoz via binary as well, you can install it on Linux system. You can install your ClickHouse, your Zookeeper, and then run the migrations and finally install your SigNoz binary. So all these instructions are pretty detailed and it helps you walk through the entire process very easily. Coming to the next one. In the Kubernetes section of it, we have install on AWS, GCP, AKS. I have DigitalOcean. You want to deploy SigNoz via Argo CD on your local Kubernetes or on OpenShift platforms. Again, these docs are pretty detailed. It covers a wide horizon of use cases, which generally was brought to us in our community, and we covered them all. So this whole theme of making SigNoz installation easy was picked as a milestone, and we delivered pretty well on the milestone. And there are other sections as well you can install on ECS as well. Again, it walks you through a pretty detailed steps of what IAM roles you want to create, what AHG template you have to create to make it work well. And last but not the least, this is my favorite part. You can deploy signals from various marketplaces as well. You have started with the popular ones. You have the Railway and you have DigitalOcean here as well. If you go to Railway, you can deploy signals to your Railway instance with just one click. We have a pretty good success ratio as well on Railway platform. And moving next, you have SigNoz listed on DigitalOcean marketplace as well. You can install SigNoz via these marketplaces and get the benefit out of the box. So these were the couple of improvements that we did on an install section side of things for open source users. And moving on to the next part of it, our next major focus would be now since the install has become a breeze, how can we make sending data to your Signal instance from anywhere and everywhere possible easy? How can we have detailed docs on it, or how can we have certain infrastructure in place that makes sending data to your instances easy? So this is going to be a very next exciting step for open source community, and we are really looking forward to making this live soon.
This is amazing. And I think I would really like to mention Nagesh here because he has been working relentlessly to make things easier for his
Yes.
OSS community. Yes, that's been pretty exciting, Vikrant. But as you say, right, like we have a set direction now. So now we have made installation very easy. Now the second step would be to make sure that they analyze it better, or what is the next step, and what are the features that we can anticipate. Maybe don't name the features yet, but at least the direction in which we plan to go ahead.
Right. So the first step was let's make the installation possible, for which we added a bunch of talks, we added a bunch of marketplaces support as well. The next one is once you have your instance up and running. So now you want to explore the product. Now you want to start observing your data. So this next very obvious section for this would be how can we make sending data to your instance easy? Let's say you have 20 different data sources, you have 30 other applications running across various environments. How we can make sending data from all of these places very easy to your SigNoz instance. So that would be our next direction we'll be leading towards, so that we help users sending data very quickly to your SigNoz instance and start getting the value out of it. Start observing your data, start creating dashboards and alerts on top of it, and get into that whole product cycle as soon as possible.
Right. So, again, do you have an estimation that how much time does it take right now to get started? Like, so we have solved the installation problem,
Hmm.
but how much time does it generally take to send in the data?
It depends upon service to service, and it depends upon how you have deployed signals and where all your services are running.
Hmm.
But generally, onboarding a service does take quite a time because you need to be sure that if your instrumentation is up to date, you want to use auto instrumentation, and you have an instrumentation strategy in your mind, very well documented. Now, if your services are instrumented already, if they are already generating data, then if you're using a SigNoz cloud instance or if you're using a SigNoz self-hosted instance, it's a pretty straightforward task. You just need to run another custom collector, or if you're already running a collector, you just need to route all your data to your running SigNoz instance. So it's easier to some respect, but when it's running cross environments, when it's running across regions, then sending data becomes a little tricky because you have certain things to take care of. You need to worry about certain security procedures and things so on and so forth. So highlighting all those bottlenecks, highlighting all those issues, dealing with them, recommending best practices is something that we are working on, this so that you don't feel lonely or you don't feel alone while dealing with all of these issues. We are there to help you. We are there to streamline your process.
Oh, that's a powerful word that you said.